During vertical takeoff, the aircraft's wings slide backward like a slider phone, revealing 2 rows of rotating duct fans. This is the have-risen CAB rights at 7X7 aircraft. During flight, the gas turbine not only powers the propellers but also continuously charges the battery pack, greatly extending endurance. After landing, no ground charging station is required. The turbine automatically replenishes the battery, allowing the aircraft to be ready for the next mission in just 30 minutes. In the military field, the X-7's low-noise characteristics come into play. The duct fans suppress noise to just 1/3 of that of a helicopter, making it nearly undetectable from 50 meters away during night infiltration. Special forces can use it to silently penetrate behind enemy lines. As for the power system, the Krot X-7 adopts a hybrid drive. At high speeds, the combustion engine delivers powerful thrust, while at low speeds or during precise maneuvers, the electric motor seamlessly takes over. With the help of a rear propulsion propeller, even if the sliding wing mode is not activated, it can still cruise at speeds of up to 400 kilometers per hour. During flight, 100 kilowatts of power is available to supply numerous sensors, equipping it with intelligence, reconnaissance, and surveillance capabilities. Perhaps in the near future, we will frequently see its presence in the skies. At a construction site, a group of robots are busily working, laying bricks and building houses. The Dutch startup Monumento has turned this vision into reality. The company has developed robots with advanced bricklaying technology, capable of working in coordination with equipment such as automated carts, liquid exhaust systems, and more. It's worth noting that bricklaying is physically demanding work, often leading to back and knee injuries, and the pay is not particularly high. Especially abroad, there is a serious shortage of labor. That's why Monumento's bricklaying robots are so necessary. Each robot is equipped with sensors and computer vision. With the power of artificial intelligence, the robots are able to learn and optimize on their own. By precisely controlling brick placement and usage, they can reduce material waste and energy consumption during the construction process, showing the vast potential of robotic bricklaying. However, the future still comes with many challenges. For example, in real-world operations, will unpredictable situations arise in complex environments? This will require more time to test and validate. Let us look forward together to the further development of artificial intelligence. We often hear that certain mechanical equipment is fitted with a gear reducer. Once this device is installed, the machine's performance can be greatly improved. So, what exactly is its function? In many cases, mechanical equipment doesn't need very high rotational speed, but rather greater power. To meet this demand, the gear reducer was invented. A gear reducer transfers high-speed power through the meshing of gears on the input shaft, then outputs it to the larger gear to achieve speed reduction. Its principle is simple. A small gear drives a larger gear, which reduces the speed. When combined with a multi-stage gear structure, the speed decreases even further. A gear reducer is a relatively precise piece of machinery. In addition to reducing speed, it can also increase output torque. That's why gear reducers are widely used in various industrial and agricultural machines. There are many types of gear reducers. Let's take a look at some common ones. Planetary gear reducer. This type consists of a large gear and several smaller gears inside, resembling planets orbiting around the sun, hence the name. Compared with other reducers, planetary gear reducers offer high precision, high transmission efficiency, and high torque, while requiring almost no maintenance. Because of these features, planetary gear reducers are often mounted on DC motors to reduce speed and increase torque. Worm gear reducer. This type is made up of a gear and a worm. Typically, the worm is positioned above, and the rotational direction is at a right angle. By harnessing motor power, it produces a force with relatively high torque. Worm gear reducers are compact in structure and provide large transmission ratios, but their efficiency is low. They are suitable for low-power, intermittent operations. Helical gear reducer. Similar to a worm gear reducer, but its gear teeth are angled. This creates a higher degree of meshing, resulting in less noise and a stronger build. The angled design increases the contact surface area and prevents disengagement. Helical gear reducers save space, are durable, and can withstand heavy loads. They are mainly used to provide medium to high-speed operation. Spur gear reducer. This type has teeth parallel to the shaft and is one of the most common and widely used gear reducer designs. It can consist of multiple gears. Spur gear reducers have a simple design, high torque, high efficiency, and are very strong and stable. They are suitable for relatively high-speed operation and are the preferred choice in many industries. Aside from the 4 types introduced above, do you know of any other kinds of gear reducers? When nuclear war breaks out, as the first line of defense protecting the residents inside, a shelter blast door must not only withstand the shock waves of explosions, but also completely block radiation, contaminants, and external threats. As one of the key engineering features for protecting inhabitants, how exactly does a shelter blast door resist a nuclear blast? Before nuclear war erupted, the Vault-Tec Corporation promoted its blast doors like this: "Sleep well, because our blast doors can withstand a direct hit from an atomic bomb, with only a 2% chance of malfunction." To ensure protection against a direct nuclear strike, the blast doors are cast from special alloy steel. Their massive, gear-shaped design allows them to fit tightly with the doorframe. When opened, the entrance is as wide as 4.52 meters. To highlight the thickness of the blast door, here's a comparison with the protagonist, though it remains uncertain whether today's real-world weapons could penetrate such a door. Of course, such an enormous blast door cannot be opened manually by staff alone. It requires the use of a large hydraulic beam suspended above the door, as well as a full unlocking system working together. To open it, you must insert a Pip-Boy as introduced by Vault-Tec and press the unlock button. The unlocking mechanism then retracts the 3 bolts inside the door. Wall clipping shows that when the blast door is sealed, 3 protruding bolts lock the entire door structure. It's worth noting that when closed, these bolts should insert into the frame. However, in the actual modeling, no fixed slots were left for them. Once unlocked, a mechanical arm pulls the blast door inward. Due to its immense weight, the bottom gear platform is needed to roll it to the right. Observation reveals how critical the unlocking system is. It must remain functional even centuries after nuclear war. That's why on the side of the mechanism, you can find an oil filler port for the gearbox, along with reminders for replacing the oil filter. Unlike many vaults designed to directly withstand shockwaves, Vault 111 is equipped with a secondary blast door to protect the elevator leading into the vault interior. Notably, this door can be unlocked via a nearby control panel, and in emergencies, it can even be cranked open manually. And that concludes the story of the shelter blast doors. This is Cole, standing as tall as the door bolts themselves. In the family of bombers, there are many well-known and famous models. For example, the Tu-160 bomber, known as the White Swan, or the B-36 bomber, hailed as the King of the Skies. These were the stars of the Air Force's arsenal at the time. However, among them, there was one bomber called the XB-70 Valkyrie, which left a particularly deep impression. Its turbulent fate has also become a much-discussed topic among aviation enthusiasts. In this episode, we'll talk about the legendary strategic bomber known as the Valkyrie, the XB-70. The XB-70 bomber was developed by North American Aviation in the 1960s. During a flight test in 1964, the XB-70 achieved a speed of Mach 3 and a flight altitude of 21,500 meters. Its maximum range exceeded 8,000 kilometers, making it the fastest bomber ever built. In addition to this, only 2 other aircraft in the world were capable of flying at speeds above Mach 3, the MiG-25 reconnaissance aircraft, designed by the Mikoyan Design Bureau, and the State Route 71 Blackbird reconnaissance aircraft, developed by Lockheed. The fact that the XB-70, a bomber, could match the speed of the fastest reconnaissance aircraft is proof of its extraordinary performance. The XB-70 achieved supersonic flight thanks to 6 General Electric YJ-93, GE-13 afterburning turbojet engines, each capable of producing 14,000 kilograms of thrust. The Valkyrie bomber's fuselage was about 60 meters long, with a wingspan of 32 meters and a height of 9.14 meters. It could carry 136 tons of fuel and a payload of up to 11,340 kilograms, making it a true super bomber. The XB-70 adopted a canard delta configuration with folding wingtips. The wingtips could be lowered between 25 and 65 degrees during high-speed flight. The bomber had a crew of 4, a pilot, a co-pilot, a flight engineer, and a defensive systems operator. According to its design, the XB-70 could carry 22.5 tons of conventional or nuclear weapons. Its massive internal bomb bay could hold 14 nuclear bombs along with other armaments. The XB-70 was also capable of rapid takeoff. In comparison, the State Route 71 Blackbird required extensive pre-flight procedures, such as long engine warm-ups, physiological checks on the pilots, and donning a special pressure suit before flight. The XB-70, however, only needed 25 minutes from warm-up to takeoff, with runway taxi time as short as 45 seconds. Pilots didn't even need to undergo medical checks, nor did they need to wear pressure suits. Flying without them posed no risk to their health. Yet despite its extraordinary performance, safety issues were a constant challenge for the XB-70. In 1964, during its maiden flight, the left main landing gear caught fire on landing. In 1965, an unidentified object entered the intake of the XB-70A, damaging all 6 engines beyond repair. That same year in October, structural failure occurred during a high-speed flight. In 1966, the second XB-70A collided with an F-104N fighter jet during a test flight and crashed in the desert. These recurring safety issues shook confidence in the program. Combined with the fact that high-altitude, high-speed bombing was no longer aligned with the evolving needs of warfare, the XB-70 was doomed to elimination before it could enter service. By the late 1960s, after completing its final flight, the XB-70 was permanently placed in a museum.